I think, as you will hear from Professor Mitchell, it is going to be a part of all of our lives. Any professions you go into, even law, medicine, healthcare, public policy, engineering, computer science, literature, psychology, but also in your personal lives, Web3 will play a major role. And I will then leave it to John Mitchell to conduct the class as he wishes. John, we have one large classroom here, but there are also quite a few people online, including some of our faculty from all three schools: School of Computing and Data Science, obviously, School of Arts and Sciences, and also the School of Law, because technology law is of interest to our law faculty. Please take it away.
Oops, have to unmute here. Thank you for the kind introduction. And I do look forward to seeing many of you in a couple of months. I was looking back at my passport. I've been to India 6 times, but all between about 2004, 2005, and 2011 or 12. So it's been a decade. I think I've been to Chennai 3 or 4 times and enjoyed it each time. And I'm sure this will be a different visit and exciting in its own way. So I look forward to that and hope to meet many of you. I think I'll share slides, and my plan is to talk for 45 minutes or 45 minutes to an hour, maybe somewhere in that range, and give you an overview of some things happening in blockchain and Web3. And then I'm going to pause for 10 minutes or whatever time it takes to give each of you to talk with each other in kind of small groups. There's a picture, a kind of graphic with a bunch of topics in it that I'll touch on in the introduction. And then we'd like to go around and get questions from some of the groups where you've talked with your friends and neighbors in the classroom, or at a breakout in Zoom if you want. And just get tell me what you'd like to hear more about, and then I'll spend a little bit of time talking about that. I think the purpose of that is twofold. One is to hear me talk nonstop for 2 hours, a little bit long. It's nice to stop and process things and think about what you've heard with few other people, but also give me a sense of where you'd like to spend the time. There are really way too many topics here to cover extensively, so I'd like to sort of dig in a little bit more in the areas that interest you. We won't cover everything there is, but I hope it gets you interested, it gives you an idea, and gives you an overview. So let me set up the slideshow here and then share that screen. Okay, now does that show properly there? Somebody, yeah, okay, good. I want to make sure it isn't the present,
Yes.
Yeah, it does.
There's sometimes 2 views in PowerPoint. I'm going to make sure I got the right view. Okay, good. So blockchain is one name and Web3 is another, and I'll tell you a little bit about how those things connect. And at the bottom, we do have a Center for Blockchain Research. You can look that up on the web at Stanford. I think before I start, I thought I'd say a little bit, since it's Friday night here. It's about 8:30, 8:45 in the evening. And it's a Saturday morning there. Most Saturday mornings, I take a bike ride. We have really nice countryside between where I live along the bay in Palo Alto, California, and up over the hill and towards the Pacific Ocean. So this is a typical turn on the bike ride up the hill to the top of the ridge of Santa Cruz Mountains. And then if I have time, I'll go down towards the ocean and come back. But we have a nice redwood trees and not too many cars on these small roads. So I thought I'd just give you a picture of California for orientation. So that's where I will likely be by the time it is here, the time that you have there. A little bit about background. You had an introduction. I've worked in a couple different areas of computer science, programming languages for a good period of time, and computer security, including network protocols. And the reason I mention these is that these connect with the field of blockchain. What's interesting are the languages we use in programming or writing contracts for the blockchain, and the protocols, the network security aspects by which different nodes in the blockchain agree. And so I'll talk about that a little bit. I've been involved in research on those things. Facebook had a pretty exciting and innovative program for about 18 months. I was there as a consultant or 1 day a week participant in that. So we got a lot of experience there in the topic area. So I don't know about everything. There's a lot of things going on, but this is an example, as you heard in the introduction, of a technology that's growing. There's a huge amount of interest, a huge amount of investment, many people involved. And I think it's reached the point where, even though it's not clear what's going to happen, it's clear that something is happening, and it will have some effect in the future. In preparing some of these slides, I had help from a former PhD student with me. His name is Mark Mitchell. We're not related. We just happen to have the same last name. And every time he shows this slide, we've done this talk together, he remarks that we also have the same haircut, which is coincidental, but so it goes. And he's been more of an entrepreneur, investor, and serial startup founder and investor in companies. So he has helped me a little bit on understanding some of the business angles here. And he wasn't able to join us this evening. But if you have questions along this line, I maybe can rope him in again. And anyway, I just wanted to give him credit for helping out on this. So let me start with just some very high level overview by, giving some definition of some of the terms, just begin to get into some of the ideas and technology and development here. So this terminology, Web 1, Web 2, Web 3, is meant to emphasize the potential application layer elements of blockchain. And in this terminology, Web 1, which was created in 1989 and sort of 1889 to 95, early days of the web. The internet already existed, so we had network for connecting lots of computers, but there wasn't a really defined standard for written information or sharing documents, pictures, video, content on the internet from user to user. So the web was really innovative in that form and gave us a kind of way of using the internet as an information sharing setup. It was created by physicists who had, data about physics experiments and video and papers they wanted to share and so on. And in the early stages, the web was really just like a linked hypertext book. A person or an organization would write a bunch of web pages, and the only thing you could do if you weren't one of the authors was navigate through and read them. But that was revolutionary in its time. There were some questions: how are we going to get around? How are we going to find stuff on the web? There was even at that point a little bit of a competition and uncertainty. Yahoo was a startup from Stanford. Two electrical engineering graduate students thought, well, the way to get around on the web is to have a group of people, a group of editors, hire 50 people or 200 people, let them read all the web pages there are in the world, produce a directory, and that'll be successful. And Yahoo was a successful company for quite a while. The competition, the competing idea there was, no, we're not going to have time for everybody to read all the web pages. They're going to be way too many. Let's build an algorithm. Let's build an automated method for searching the web. So our company, Alta Vista, was earlier. Google was a little bit later. They said, well, let's produce a way to search the web and not worry about being editors or trying to decide which web pages are important by reading them. And you can see now Yahoo's long gone. Jerry Yang and David Filo, who founded the company, became, financially successful, did a lot of other great stuff. This idea just only went so far, and at some point the web got too big for people to read it and scale it. And Google, of course, is one of the largest company in the world. So I point this out both to give a little bit of sense of the history, but also at the time, we had no idea which one of those was going to be most successful. And certainly at this time, there are a lot of ideas in Web3 that all seem kind of good. Some of them will be winners like Google, and some of them will go, fall along the wayside like Yahoo. And we don't know yet which way things are going to go. Web 2 was the innovation of the web where users could write input into a web page. So if you go to Facebook or some social media site, you can type stuff in to the page on the web. That was not part of the first 5 or 6 years. It then evolved. And the email client, all of these things, the ability to buy stuff online, order things, shop, all this came along with what's called Web 2, the idea that users could write into web pages have input forms. And then we got things like passwords, ways to transfer, credit card numbers, buy things, e-commerce, social media. There's a big, it developed from 95 to 2004, but, obviously has been with us since. It's been important development. In the context of the success of Web 2, calling something new Web 3 is a little bit presumptuous. It says we're going to be this idea is going to be huge and important. But I think there's some sense that it may be. Web 3 is characterized by decentralization. Some site could be distributed and stored many places instead of one place. And I'll give you some examples of the kind of things that can be transmitted. Currently in Web 2, there really isn't any web-based way to send money or buy transactions. We're really relying on the historical banking system. Web 3 might change that by using blockchain technology. So I'm not thoroughly defining it, but I'll go through, and most of the talk is about, what is Web 3? And the important thing is not really what does the term Web 3 mean, but what's happening now? How might it change the world? Where is it going? And if you're interested, how can you participate? All right, so some key other terms here, blockchain. I'll have a picture in a minute. The phrase, if you're going to remember one phrase about blockchain, it's 3 words, still kind of hard to remember: verifiable public ledger. Verifiable means you can tell that it's correct. Public means anybody can see it. And ledger is a term that comes from accounting. It means you can add things to the bottom of the ledger, but things that were written there before still remain as a record. So it's a read-only, add-only data structure. And the fact that nobody can erase things means it's a reliable record of the history. And it's maintained in a distributed way. Cryptocurrency is one use of blockchain. You're probably, many of you, familiar with Bitcoin, Ethereum, different kinds of currency. Bitcoin was the first one and the one that made the biggest, kind of splash. Bitcoin uses a blockchain, the Bitcoin blockchain, to keep track of who has the money. So if you have owned Bitcoin, it's recorded on the blockchain. If you sell it to somebody else or use it to buy something, the fact that you transferred ownership to somebody else is recorded on this Bitcoin ledger. And that's how the blockchain keeps track of who has what money. And that's kind of essential to a monetary system. If people could steal your money or forget that you owned it, it wouldn't be a good, basis for finance. Smart contract is an evolution over blockchain. This became possible in Ethereum, the second big chain to develop after Bitcoin. And here, what's interesting is, since this ledger, this data structure of recording things, is a computer system, we can write into the ledger a program. And so instead of just having a piece of information that says Joe owns this Bitcoin, we can have a program written into the blockchain that says, whenever the date becomes January 1, 2023, my digital money will be transferred from me to somebody else. I'm going to give it to charity on that date. And if I write that into the blockchain now, and that blockchain controls that currency, it will do that on January 1. So you can write contracts, agreements, plans for something to happen into the blockchain, and they'll be executed automatically by the blockchain. And if they move money around, that'll happen automatically. So super, really big thing you can't do with a bank. You can't write an arbitrary piece of code and send it to your bank and have your bank, run it whenever it's time. So, kind of an advance. And with that comes this idea of tokens. So token is kind of a way of using contracts. A contract can be whoever, is recorded here owns a piece of land, in some part of the world. And then that token, if you transfer it from one person to another, you're transferring ownership of a piece of land. There are things called NFTs, which are non-fungible tokens. It means it's a token that's about ownership of a specific good. So you can have a token that says, this is a signed copy of a piece of digital art, or this is a signed picture of a sports athlete, a famous athlete, sports figure signed by that sports figure. And then they can be traded or bartered or something. And I'll say a little bit about that at the, later on. And maybe some of you, have done these things. Actually, maybe try that. Especially it's easy for me in the classroom there. If anybody owns an NFT, would you wave and make a lot of noise, or let me see you on the small camera here? Anybody in the classroom there own an NFT? Doesn't look like it. I can't see there. It's kind of small picture. It's something you can do if you want. So I'll leave that up to you. Oops, something went forward here. I was trying to look at you. Okay. Anyway, it's if you're interested and you're curious, you can go buy an NFT. You'll have to install a digital wallet in your browser. You'll have to put a small amount of money in it. You'll have to go to some site and buy something. And I hope nothing bad happens. If you lose your money and it's only a few rupees, let me know and I'll write you a check. If you lose a lot of money, then I'm sorry, I can't help you out. So don't risk a lot of money doing it, but you can do that. You can give it a try. Okay, that's kind of the terminology. Let me say here's kind of the map of things we could talk about when we get to a little discussion session and you want to talk with your friends about what would you like to hear more about. Here's kind of a menu of things. On the left hand of the picture is how does a blockchain work? What's the technology about? They're what are called open and closed blockchains. There's different ways they work. There's a lot of details in it. We could spend 6 months studying how that works. Then there's the notion of ledger, which I mean, what are kind of the ledger-based applications? Things just involve recording stuff on the blockchain and having it be really useful. So if you have a supply chain, who's manufacturing parts for automobiles, which automobile manufacturer buys those parts, who has supply of them, who has demand, how are the things get, supply chain, nice thing to have on a public ledger. Things like real estate ownership, things like this. I'll give some examples. That's one area. The whole area of finance is big. People are speculating in coins. I mentioned wallet. If you want to buy an NFT, you'll have to have one. Contracts, loans, crowdfunding, shared ownership. We could talk a little bit more about that if you want. Or, how does Web3, what's the fringe here, the future and more recent things, collectibles, some kinds of contracts and how they're used. So we can come back to some of these. I'll also touch on many of these. I'm going to focus on applications to give you an idea of where this is going, but we can go back to how things work in more detail or any other kind of question you want at some point. So let me start with this example. I think it's as good a place to start as any. The idea of medical records. Different countries have different medical systems. In the US, it's mostly private medicine. different companies run hospitals, clinics, doctors work for those companies. The way you pay for medical treatment is you get insurance from a company, and that insurance company pays your doctor or your hospital or clinic or lab when you have to do this. And people, through their lives go from one doctor or medical provider to another. If you live long enough, like I have, you have, some history, some things that went wrong, some things that went right. I got injured. I have broke some bones. They fixed in a certain way. Some people are allergic to things. Those could all be stored in your medical record. And if you're traveling somewhere and you get sick or you get injured, people would want to know right away, are you allergic to some sort of drug that they would give you for treatment and so on. So the medical record kind of follows you through your life, but it's written by many different providers in different places if you move around, and it's useful in many different cases if you go around. So one of the key things here is, at least in a context like the US, not clear who feels responsible for storing your medical record. So if we had one shared system for doing that, maybe you can think about international travel. When you travel internationally, how can someone see your record right away and know that it's correct and so on? So here are some things that people think about. Who can read and write your medical record? How do you know the data is accurate? What happens as you travel around the world? How can you access this? And, would blockchain be a good recent way of handling this? And here I'll just use this to explain this term I used before, trusted public ledger, or trusted and verifiable are kind of synonyms here. If you had one place, like if you had a national health service, you might have all of your health records stored in that national health service, and that would be for your region or within your country, the centralized approach. Decentralized, a blockchain means copies of this record or copies of anything that's in the blockchain are stored multiple times, many different places. If one of those computer systems loses power, gets hacked, there's an earthquake or a fire and it goes away, there are many, many other copies elsewhere. And the different owners of the different sites make sure that they all agree on what the current record is. And that way you have a certain degree of trust and you can tell that it's accurate. A centralized party hasn't cheated or lost track of a record. And this, notion of being a blockchain is we never throw any information away. We just add new information. So is this useful for medical records? Blockchains are useful when the data you're storing has a long lifetime. It's useful for a long period of time. There's no clear, centralized single party who wants to keep all the information and would do a good job of it. And sharing the information is useful. It's even more useful when you want to see what's the history, because a ledger stores history. And even more useful if there's some market for exchange. And that comes up not so much in medical records, but in other cases. So if we store, we kind of look at that here. Medical records have a long lifetime. They last as long as we do. It's not clear that any one laboratory or any one site will store this for you and make it available to anyone who needs it around the world. And we'd like to know if you see some information, is it reliable? So it meets the basic criteria for that. Let me give another example. This may be feel more personal to some of you. I was on the steering committee for an effort with the US Department of Education to look at whether blockchain technology would be useful in education. And we in that project funded 4 pilot efforts to explore use of blockchain in education. I'll mention 2 of them. One of them was in a particular location, the city of Dallas. And the blockchain was going to store educational records. Who took what class? What grade did what marks did they get in the class? Did they graduate from that institution? What did they study? The blockchain was going to store that kind of information for all students of all ages, for every school within the city of Dallas and the surrounding smaller cities that are also there in Texas. And so this was meant to say, if you, whatever you did, if you started in one school, you transferred to another, you completed another class at a third, no one of those schools would have to be responsible for storing all of your information. And right now, no school does feel responsible for storing all of the information from all of the education you had. But the blockchain would be one single place, distributed and replicated many times, that would store all of the information about educational credentials. So you can imagine, suppose you go to college in India, and then you want to come to the US for graduate school. That happens to a certain number of students. At least I meet students like that. And, some, I'm sure Psy University is, feels generous toward you, and they will always store your transcripts and whatever anyone else wants to see them, they'll send them. But, some other colleges in India are not set up to do that at the scale of the number of students that go through. So if there was an international blockchain that stored everything you've done educationally in your life, you could use that and it would be beneficial. So that's one example. Another example from this case was instead of regional, a certain kind of education. The second example was for teachers in the US school system to keep track of the classes they took, to keep their teaching knowledge up to date. One of the requirements that's present in most school areas is if you're a biology teacher in high school, let's say, then you have to take a certain number of biology courses in the summer over, from year to year to keep your biology knowledge up to date. Those can be recorded on this teacher credential blockchain. And that way, the teachers wouldn't have to store them. And because they were stored in a blockchain in this verifiable way, anyone looking at those credentials could see they were correct. That solves the kind of problem that a person has if they have a piece of paper that looks like it's a signed credential, but it could be forged and there's a problem of trust there. So I thought that was quite interesting. Both of these were successful and the other ones were too. In the second case, I wanted to make another point about it, which is the blockchain was created to help teachers prove to their school systems that they had satisfied a certain requirement. But another unanticipated use came up, which is once we had this big record of who was up to date on teaching, that became a tremendous place for schools to look for teachers and try to hire them away from other school systems. If you were a teacher in a school system in Kansas and you needed a biology teacher, here was this big database showing who was up to date on teaching biology, and you could go offer them a job. So I think that's really a sign that the technology is useful. What's great to see happen is you build a kind of setup for one reason, and then if it has 10 other good uses, then you can see that it's going to be promising. So I want to mention that example there. There's lots of thought of whether blockchain would help modernize the banking system. Right now, if I wanted to send money to another person, we exchanged something. I went to they posted something for sale online. I wanted that thing. I went to their house. I got the bicycle or something from them. If I want to pay them, it has to go. I have to send message to my bank. My bank has to transfer money to their bank, and then they get the money. This whole banking system is most of what happens there electronically is really derived from the era of paper banking and banks sending letters and messages back and forth. In the US, it takes about 3 days for a transfer of money to go from one bank account to another, even though it's all automated and electronic. Some of that 3-day time is implement some things to prevent fraud, but it's not too quick. And sometimes those delays are significant and have business problems. If all of your banking information, the amount of money you had and where it's stored and your ability to control it was written on some big global blockchain, you could transfer that money instantly, electronically, much more cost effectively too. So there'll be some problems of working out fraud detection and so on, but the potential is there, and a number of banks and banking kind of investment firms and so on have looked at this in the future and believe something is going to be better there. I think anyway, I'll leave it at that. There's lots of areas of issues there, and likely to be some progress, I think, and some controversy, because banking systems are, people who run banks, are cautious about change, let's say, because there's money involved. I'm going to say a little bit more about smart contracts. Here's a little bit of a picture, and you can read more about it there if you want. Smart contracts, as I mentioned, are code, a program written on a blockchain that gets executed. The program gets run whenever some conditions happen that are written in the program saying it's time to execute. And the code can be, everyone can see that that's there and that the thing is going to happen. And maybe a good example is a loan would be a very good smart contract. If you were an Ethereum user and you wanted to loan some money to someone else, you could write that as a smart contract. Of the kind of loan that I have in mind is, I'm going to transfer money to you. I'm going to loan you some money. And then you're going to pay me back month by month over, let's say, a 2-year period. We could write that out as a program that on January 1, I transfer this amount of money, and then February 1, March 1, April 1, et cetera, you're going to transfer a certain amount of money back. So I see that there might be a problem with audio. I'll hope to let me know if there's a way to help with that. In this contract, in this loan case, the program is clear. On one date, one payment will happen. On some other dates, some other payments will happen. And if we agreed to a loan, we could write that program into the blockchain, and everything would happen according to the program. We wouldn't need a lawyer to define the terms of the loan. We wouldn't need a bank to do it. We could do it all by writing a computer program. So I hope that example is clear. Please ask questions if you have. I'm happy to stop and answer a question if anything is not clear. In this context of smart contracts, there's another concept called DAO, Distributed Autonomous Organization. It's a fancy term for saying we've agreed on the terms of an organization that's like a company or group shared ownership, and we've written it into a program. The program would say the rules for voting to make decisions, or who can join the organization, or if somebody decides to leave and they had to pay money to join, do they get any money back? All of those kind of things can be written into a program that kind of becomes the rule of law for the purpose of the organization of that community. An example is something called City DAO, City Decentralized Autonomous Organization. This was created in the US state of Wyoming. The City DAO initially collected money from people who wanted to join the organization. With the money they collected, the DAO itself became the owner of 42 acres of land. That's a modest size, a place you could build I don't know, 150, 200 houses, for example, in that amount of land. And then ownership and decision of what to do with the land was done by this DAO according to the votes of people who were registered members or authorities of this DAO. And in this, I think the reason they started in the state of Wyoming is Wyoming has an innovative law saying that a DAO can be registered legally in the same way as a company. The specific kind of company is called an LLC. I don't think that's so important. Basically, a DAO, a piece of code written on a blockchain is treated in the state of Wyoming as equivalent to a private company founded with legal contracts written by lawyers. So it's a beginning of this transition that you can see probably will happen in other ways, where programs and code kind of become substitutes for lawyers and laws and legal contracts. There's a famous kind of phrase from a lawyer, we have an echo here, named Larry Lessig, called "Code is Law." And this is an example of that phrase. Was there a question? I have an echo from somebody. So if somebody did something with their microphone, would someone like to ask a question? So let me go on to one more kind of even more futuristic example than creating a company by writing a computer program. This example I like very much because it illustrates the potential to trade and create a market for something where there is no market now. And I think this could change this environment around music, and it could, similarly, there could be other kinds of new ideas in other fields. And maybe when we stop and you have a little time to think about it, you could think about whether there's another topic area where something similar could happen. There's one company that I've listed here, and it's one of many. If you look online for this company and what they do, there will be others that do something similar. This one is called Royal.io, and it's meant to create something digital on a blockchain that replaces the function of a music record label. So one of the ideas here is that an artist, a musician, a rapper, someone who creates music and records it could then, immediately after they record the music, offer for sale a contract or an agreement that gives the buyer a fraction of the money they make from recording this song. So you could sell 1% of all future income from this song right away, right after you record it. Or you could sell 0.5% or 10%. So that's what the musician does, is record music and then offer for sale percentages of the money that will be earned by that recorded music. What a music fan does is listen to music and decide which of these investments to make. So if you really like a certain kind of music, you think some particular recording is great, you think people will play it at parties, or it will be played in places where there's royalties paid for playing the music, you could buy a small fraction of that future. If you do that, one thing that happens is the musician makes money right away. They're selling this contract for future royalties, probably get a fraction of the royalties they might get. But, musician needs to live, eat, pay the rent for wherever they live. This would provide instant income easily to musicians. And then if you were a fan and you bought music, you could show your friends, try to make the music more popular. You could get your money back if the song is popular, or if it starts to be popular, you could decide to sell your contract, giving you future royalties to someone else who likes the music. So there gets in the system a market for these tokens, they're called, that each represent possible future income from playing music publicly. So it's a little bit complicated. There are lots of parts of this, but the setup allows you to own a piece of a song as a fan. It allows the fans to share in the financial success of music. And it gives musicians a different source of income that's just based on somebody liking their music. And then another fourth part of this is that if you were a musician or artist, you would have an instant way of recognizing people who are your fans or who liked your music. They are the special people who invested in the future royalties of your song. So you could say, on Saturday afternoons, I'm going to be online and I'd like to talk with my fans. And if you are one of my fans, you use this contract you own to prove you're one of my registered fans, and you'll be able to join a Zoom call or a virtual concert, or you could come in person and use this as a ticket to get in. It's a way for artists to interact in different ways with their fans. So I hope I've explained enough about this that you can see that even though this is kind of hypothetical, it's early, we don't know whether exactly this will catch on, something like this, but it has a very different set of benefits for artists, for musicians, than the current setup of recording a song, trying to market it through record labels, trying to get it promoted, trying to get revenue from music sharing sites based on the number of plays and advertisements or other things. It's another financial ecosystem around a particular thing, music. And I wanted to give this both because I think it's understandable, but also maybe to help you start to think about whether there are other things besides music where it's possible that with a new technology, we could create a new market for digital goods based on that activity or kind of good. Another example are these sports trading cards. I don't know if that's popular with any of you. When I was a kid, we used to have little cardboard cards with pictures of baseball players. And if you liked a baseball player or liked a baseball team, you would collect the cards and pictures of them. And if you were lucky and got 2 or 3 cards from players that you liked, you could trade them with one of your friends so that to get a card that you didn't have. And people would collect these things and trade them. There's a whole building industry around sports, connecting with sports as fans based on tokens on the blockchain. Lots of possible futures, kind of like this example I gave with Yahoo and Google. We don't know exactly which one of these is going to be successful, but I think there's a good indication from the amount of activity the number of people who are interested, the investments from sports teams, the investments from others, the number of startup companies, the total monetary value, which is in the trillions of dollars of cryptocurrency today. There's an economic sector and a set of possible activities that could be done very differently in the future based on this kind of technology. And that's what this term Web3 is meant to encompass, is all of the different things beyond just trading Bitcoin that could be used, enabled by blockchain technology, and help allow new possibilities, not necessarily all possibilities you will like, but things that are enabled by technology that will change the way people interact. So I hope this gives you a beginning of the idea of a number of applications, databases of records, like store what happened medically to someone, store what happened educationally, store what happened in the production of food. Is this wheat, corn, was it grown organically, rice, where did it come from? Lots of things in supply chain are like that. Things like this music contracts, where will that happen? And then many, many more kind of opportunities to change the way we do money and banking, change the things that people invest in, and so on. The financial infrastructure and other things could change dramatically. So that's kind of my overview. I guess the last thing I want to say is, in this overview part, I gave the examples so far of what are some possibilities, how could they be successful in a business sense, or how could they solve problems and make the world better in some way. But this is a technology that's not perfect. It's a technology that's evolving quickly. And because people are trying to do things quickly, there are vulnerabilities, attacks, mistakes, bugs. And if you're interested in computers and how things work sometimes, but things go wrong, there are lots and lots of examples here. So I have another picture, another slide explaining the DAO hack and how that worked. Most of these are technology problems, but they caused real loss of money. And let me just use the DAO example. So you have one specific here. The first thing called first DAO, Distributed Autonomous Organization, was called the DAO. And it was a contract for crowdfunding. That's for allow a group of people to each contribute to funding something. And they were going to buy something. This contract raised $150 million. That is, I don't know how many people, but certainly more than 150 and probably fewer than 150 million. Each contributed some amount of money for this purpose. And then somebody was able to use a software bug in the contract and steal about $60 million. This was at an early time in the blockchain. And what happened is, to resolve this, the people involved in the DAO explained to the governing organization of the blockchain that there was a mistake in their code. It was easy to see the program was written to work in one way, but a clever, malicious input to the program caused something else to happen. And so it really was a mistake that one person was able to steal money and take money out of the crowdfunding contract. So the blockchain itself, blockchain organization, decided in effect to roll back time, go back to the time before this contract was created, and let them start over with a different code for the contract that didn't have the incorrect software behavior. That's very unusual because it takes an entire system worldwide governing the transfer of money and the commitment to contracts. You have to cause all of that to go back to yesterday or the time before. But at this time it happened, $150 million was significant relative to the total amount of currency on that particular chain. And so this was the resolution. This details about it being called a reentrancy attack have to do with the language solidity that's used with the Ethereum blockchain. So that's a kind of a detail for the computer scientists or people who are interested in coding on this. And there's some line of code, you can look it up and find it if you're that kind of person. But it's really
excuse me, John. So
yes.
I have one question about the DOA example that you just gave.
Yes.
This is Kavita.
Yeah, hi.
Yeah, hi. So you said they rolled back to a time before the attack happened.
Yes.
But that doesn't still recover the lost 60 million, does it?
True, but it keeps someone else from getting more of it, I think is the best you can do. I think we'd have to look up exactly what happened there. I think you can, it depends on what, if this were, suppose this is Ether is the currency, and this is on the Ethereum blockchain, then the ownership of that money is entirely under control of that blockchain. And then you could roll it back. If the person had been able to transfer that from Ether to dollars or Ether to rupees, then you might have some action that was outside control of the blockchain, and rolling it back would not, recover the money. So I don't know exactly what happened in this case. This is 2016, 6 years ago. We could look it up.
But in general, I mean, so if somebody does transfer money and then, transfer it to the currency, hard currency, there is no way to roll it back.
Yeah, that's true. So in some times there's a method to recover. This is not a good method to rely on. This is just a thing that happened in this case. But there are billions of dollars lost per year due to software errors in code that moves money around on blockchain. It's a good point. Thank you for raising the point.
Okay, thank you.
Yeah, thanks. To give another kind of example, I recently organized a conference at Stanford called the DeFi for Decentralized Finance Security Summit. We had 1,200 people sign up to come and participate in the conference. Fortunately, only about 400 of them actually came. We didn't have room for them. But the conference was full of people focused on this narrow kind of problem of how to find software mistakes that would cause someone to lose money and how to prevent these things from happening in the future. There are many people involved who do review of code to look for errors like this one. And it's a very good business to be in if you're skilled at that process of auditing, you have lots and lots of business opportunities now. One thing I learned in that is the kind of code that's most heavily attacked. And it has to do with exchanging one cryptocurrency to another. So if you were to start a company or create an organization that would facilitate the exchange of Bitcoin into Ether or Ether back into Bitcoin, the code that is allowed to do that has to be able to destroy Bitcoin and create Ether. So any piece of code that has the permission to destroy money and create money is a really good target for someone who's a malicious hacker. They would want to cause the part of the code that creates money to create money for them, and or cause the part of the code that destroys money to destroy money from other people to create havoc. So there are a number of these companies or startups or organizations called bridges in the decentralized finance field that provide this service. And there's a lot of technical question about how to do that securely so that money isn't stolen. All right, so maybe this is a good place. If there are other questions, I'd be happy to pause for a minute. And then we might see if it's a good time for you to just share thoughts with someone sitting near you, a few people, and then come back with some areas that you'd like to talk about, that you'd like me to talk about in a little more detail. There's a specific question here. I don't know how many people can see the chat. It says, with respect to Ethereum, what is the consensus algorithm? So to explain the question a little bit for everyone, Ethereum is this blockchain that supports these smart contracts, and the Ether currency. The blockchain is built around a way for a large number of computer systems that record what happens on the blockchain to agree on their, so every one of those systems has to agree with all the others, or the majority of the others, on what transactions happened. That process is called a consensus algorithm. It's a very, very interesting question. And the reason is that the Ethereum consensus algorithm has changed. So this is now going into kind of the lower left corner of the picture that I have on the slide. But I think it's interesting enough to take time for everybody to talk about it now. It's one of the most publicly recognized issues in blockchain. Bitcoin has a consensus algorithm that requires a huge amount of computation. In deciding what Bitcoin transactions actually occurred in the last period of time, the last hour, or some fixed period of time like that, many, many computer systems around the world are competing with each other to see which can do a tricky randomized calculation fastest. And that causes each of the Bitcoin miners to use a vast amount of computational power. And this is environmentally not good. The thing that they're using all this computational power for is simply to decide which of them gets to go next. It's not doing actually useful work in any other sense. That protocol is called proof of work. And many people whether they know a lot about Bitcoin or not, are aware of this large amount of work. And they think of blockchain as being environmentally bad, environmentally unsustainable, bad for the environment. Ethereum has recently switched over just this year from a proof of work algorithm to a newer thing that's called proof of stake, which doesn't use the same kind of computational resources. It's designed to be environmentally better. When one of the sites says, oh, this is what happened in the last hour, they are putting some money at risk, some Ethereum at risk, and saying, believe me, this is what happened over the last hour. If I'm proved wrong, you can have my 500,000 or $1 million or some large sum of money. And that's meant to incentivize the nodes that are involved to tell the truth. And it doesn't involve this huge amount of computation. The switchover just happened recently. And so it's we're in a period of trying to figure out, did the governing body around Ethereum make a good decision? Is the new protocol going to work well? We're in kind of a testing period. And there's lots of scientific study around changing this and so on. So that's a really nice question. You can look it up. It's a new proof of stake algorithm. So I could go through these. I just have 3 or 4 here. Let me try to answer the specific ones and then take a quick break to talk with your friends and prioritize what you'd like to do next. Do you think cryptocurrency will be the end of centralized banking? I mean, there's a very simple answer, which is no. And then there's a more nuanced answer, which is in some ways, yes, and in some ways, no. So one part of my personal view is that managing a currency is a complicated thing. If you're the central bank of any country of any size and you have an independent currency, there are things that central bank does to support the economy in that country, the economy in that region, that are complicated. Stabilize the currency, stabilize interest rates, avoid inflation, avoid recession. Those things are all important government functions. And they're currently associated with national banking systems, centralized decision-making in some way. And I think those functions are important and they are likely to continue. And governments do have the ability by law to make some rules about what kind of instruments can be used as currency. So I think it's going to be in most countries and most regions like the EU's interest to make sure that there can be financial management. That's at the large scale. At the small scale, will mobile phone apps that are used to send small amounts of money from one person to another, will they become independent of the banking system? I think probably. I think there's a good chance of that for someone to send the amount of money that's associated with buying a meal together, sharing the cost of a trip for a day or a week, those kind of modest amounts of money, I think we'll have some lightweight ways to send that around that will be different and will be somewhat independent of the banking system and like the cryptocurrencies. That's my guess. Which programming language is preferred? I think the situation here is there are many better languages than the ones that are standard. But when a language is standard, it's very hard for it to be replaced. So I think that where I've seen most of the activity in making programming possible, efficient, easy, reliable, it's in building new languages that can compile down to the existing blockchain languages. Move, M-O-V-E, is a language that I worked on with the group that was at Facebook. You could look up that as an example of a more thoughtfully designed programming language than Solidity or the historical ones associated with blockchains. There's a question, what kind of research is going on? I think the most significant is the issue I mentioned about proof of work to proof of stake consensus. The other has to do with programming languages and systems and how to make it possible for people to write smart contracts that don't have small errors in them that let people steal money or violate the contract. What are some other applications? There are many, so I think I'll pause that. And then there's this a comment here from on the energy and electricity, which I think falls under the category of proof of stake or proof of work. So if it's okay, Kavita, did you have another question, or is your hand still up, or is this a different Kavita? I can't hear you, so if you want to ask a question, you'll be the last, and then we'll take a short break and people can come back with more questions.
Rita, you can speak.
Sorry, yeah, thank you. So this is mostly a theoretical question. And so it looks like a blockchain is much like a big global database. So what exactly is the meaning of having a decentralized database? So it's like a database, right?
Yeah. Okay. You know what I think I'd like to do, if it's okay, is pause on that question and come back to it. If you'd like, and we're going to have a distributed consensus problem on deciding where to go. But I have a few slides in this set that really walk through that. And it has to do with this consensus algorithm. So the short answer is, remember the phrase consensus algorithm. And if you were to look that up and read more about it, that would tell you more about what you're asking. Okay.
And one last thing in that respect was about computational power. So computational power and storage power on the side of users, does that change drastically when we go to blockchains from databases, traditional databases?
There's a replication issue, but there's a way to sidestep that by storing the hash of a large amount of data that's stored once. And so the blockchain doesn't actually have to contain literally all the data. It could just contain some information that's used to check the integrity of the data stored elsewhere. So that's a way of saying, no, we can have the efficiency of databases and the advantages of blockchain kind of simultaneously. Okay.
Yeah, thank you.
All right, good. I'll come back to the bunch of questions. Let's take you tell me when the break's over. I'd like just a couple minutes, but I think it's good for people to talk with each other and, you know, see what you think is interesting here for a couple of minutes. Let's see if that will work. Will that work in the classroom there? You have a way of doing that? We talked about
I think we can. This is Siddharth here.
Yeah. All right. So it's hard for me.
So we have 40 minutes left. Maybe we'll give them 7 to 10 minutes to discuss, and then we'll get back for questions.
Yeah, just like if each person wants to get together with 3 or 4 people and decide what.
I think they're all sitting in rows, and each of them can discuss with people in their rows. There are 3 or 4 of them in each row, so I think
Great.
that
I
should
think we'll get slightly better,
Yep.
more thoughtful questions that way, and then it'll give everyone a chance to interact.
Okay, please come back. John, I think some students, when they heard the word break, they decided to go take a break, whereas what you meant was break out.
Yeah, it's it's a risky move, but I hope we'll have a net positive impact here. I can see that there's a little delay, but they're good questions that people are typing in during this period. So hopefully good thought as well. There are a couple of thoughts based on the typed questions, but maybe it's good to hear from a few people in the room if you want, whenever you'd like to do that. I'll let you decide since I can't see the room and you can. So.
Okay, I think we're ready.
Good. Well, I'll let someone there decide. One way to proceed is just to respond to some of these questions about distributed trust and what that is. Another would be to take, maybe take 3 questions from the room and then I'll try to mix things together.
Are you going to ask any breakout groups to report?
Yeah. Why don't we do that? If you have, if you can manage that in the room and pick a few groups, as many as you think will be productive, and then we'll hear what people want to say. That'd give me an idea of what the tenor is here and what to do.
Good evening, sir. So my name is Prince Raj. So my question is that to get into blockchain, is it pre-required of coding?
All right, good question. I'd say it helps, but not necessarily. It depends on what you want to do. I think certainly you could start to participate as a user and try to understand how things work without coding. So if you wanted to install a wallet and participate in a market such as this music market, pick something you're interested in, or get together with your friends and see if together you can find an activity that's a user level thing. You could do that right away without coding. If you want to build your own blockchain or develop software that's sophisticated, then that's a coding issue. There's no simple answer, but those are some examples. I'll take another question.
Yeah, hello, sir. I'm Abhishek from the School of Computing and Data Science. And my question is that, what do you think about security and policing when it comes to cryptocurrency? Because even though there's no such system of people to help make it more secure, blockchain technology by itself is a very secure way of storing information. So if people were to hack with cryptocurrency, how do you think they could do it? Because by far it seems very impossible to hack cryptocurrency.
Okay, so I think it's very unlikely, or there are very few direct hacks, for example, on the implementation of Bitcoin. There are some ways that people have been able to steal money through the kind of example I gave before, something called a bridge between two different currencies. There can be different currencies built on top of Ethereum and then a bridge between them, and that's an opportunity to steal money. I think fundamentally, one way you can think about it is every financial system has a little bit of vulnerability. And because of trade-offs involving usability and security, we might just have to live with some degree of theft in almost any financial system. If you look at credit cards and their use, there's credit card fraud. There's fraud by people who try to steal credit card numbers and use them. There's fraud by merchants who try to claim that something was purchased when it wasn't. There is fraud in the credit card system, in the banking system as we know it, the conventional banking system. And banks and institutions have decided kind of collectively that in order to make it easy for people to purchase things, easy for merchants to accept credit cards, they're going to accept a certain percentage loss due to fraud as a cost of doing business. And I think that's probably the way most future financial things will work, is that, there's a little bit of risk, but the risk is distributed, it's small. There's an insurance business in blockchain, and the insurance business is a way of spreading out that risk. So if you were to have a wallet and an amount of cryptocurrency, and you bought insurance as part of your activity in cryptocurrency, then if you were one of the few unlucky people that had money stolen, the insurance company would cover that. The insurance premiums that many people are paying would be used to cover that, and you would spread out the risk. And that would be similar to what happens in current banking, where banks, credit card issuers, other participants in the conventional financial system cover some occasional losses by rolling that into their cost of business and spreading out across all of their customers.
But are there insurance systems for cryptocurrencies, like how there are insurance systems for traditional banking?
Yeah, this is the new evolving space. And so insurance operations are new, but they are occurring for exactly the reason I described. There's a business opportunity. If you provide insurance, that's a useful product for someone who wants to use cryptocurrency but is worried about loss. So you can go buy insurance. Take a look, go do a web search for, cryptocurrency insurance, Bitcoin insurance, blockchain insurance. You'll find some startups, small companies, organizations that are working to provide that.
Breakout group report, please. Please go ahead. Oh, yeah.
My name is Radyaksha. I'm from the School of Computing and Data Science. So we learned about when it makes sense to use a blockchain, like for example, in education and technology, and when we need to maintain records. But when doesn't it make sense to use a blockchain? Can I use a blockchain for my personal use? Can I set it up? Is it like, how does that happen? Is it an expensive process?
Let's see. So I have two answers. First of all, a significant amount of work is involved in completing a transaction on a blockchain. And the reason is a lot of different computer systems have to agree on a transaction in order for it to be recorded. So there's a lot of communication, computation, and work. As a result, most blockchains have a transaction fee. In order to have a transaction occur, somebody has to pay for the computational cost of doing it. One term for that is gas. You have to pay for gas for this machine to execute and do this. That's a technical term. If you look up gas in blockchain, you'll see that that's what it's used. So the transaction cost can be large. There's another technology. It goes by the term layer 1, layer 2, layer 3 that is used to amortize the cost of a transaction over many transactions. But essentially, the simple answer to your question is there's a transaction cost that's similar to, you can think of it, the transaction cost of using a credit card to buy something. Somewhere in the process, the merchant or somebody is paying someone for the efficiency of the credit card and the features it provides for every transaction. And something similar has to happen here. So I think if you thought, hey, blockchains are great, let me write my blog on a blockchain, that's going to be expensive if you decide to use an existing financial blockchain just to write down your information. But in the future, there may be a service that says, I'll provide a way for people to record and store information. We'll find advertisers to cover the cost. There could be a business model around it, but as an individual, the transaction cost is significant and would probably prevent you from doing it.
Mm-hmm. Thank you, sir.
Sure.
Greetings of the day, sir. It's
Yes.
Shagun Shukla from School of Computing and Data Science. And thank you for giving this opportunity to break into groups, for we came up with a number of questions. The other member of our group are Rishikesh, Dheeraj, and Abhay Singh. So our first question is, in smart contract, what if someone wants to terminate the contract before it gets executed?
I think that the short answer is this code of law kind of answer, that once a contract is committed to the blockchain, the only options you have are those that are expressly written into the contract. So there isn't really a way to change your mind. That's kind of the problem. It's both the benefit. If you made an agreement with someone else and you want that person to stick to the agreement, the fact that that contract is there and not subject to change is to your advantage. But if you have remorse or things change and you wanted to get out of it, there's no a priori way to do it. Now, maybe another layer of this is a lot of legal contracts have some clause that let people terminate the contract under certain conditions. So if you anticipated some change, you might write that into the contract. And maybe this is a good illustration of why the field of writing smart contracts is complicated and why there's evolution in tools and methods for doing this.
Thank you, sir. Our next question is, if something mishappens in blockchain technology, who will take the accountability?
That's kind of the, there in some sense, there is no accountability, or there is limited recourse when things go wrong. Some people under some conditions have lost very large amounts of money, and there hasn't been a way to go back and fix the problem. So unlike a situation where if you have a company, there are founders of the company, there's a president of the company, there's management. If the company does something that seems really dishonest, you can go sue them in court. If you have something, an entity that's a DAO, it's just a program and it's written to the blockchain and it's going to do something, then it's not clear what to do. So this is just a complicated, there's a set of questions there that don't have answers. If you're interested in this, you know, there's a chance to kind of think about that a little bit. Good problem for lawyers. What should happen if something is morally, ethically, legally incorrect or unacceptable, and it's written into a contract and it's going to do something? Who's liable? What goes wrong? Who would be accountable?
Okay, sir. Last but not the least, it's not specifically related to blockchain, but more of cryptography. Do we have any standard way to check whether our cryptographic technique is secure, other than a group of people having expertise in that field performing cryptanalysis, so that if they're able to break the code in to derive the message behind it, and if they're not able to do that, they like make an assumption that that particular thing is secure. So, but it's just an assumption. What we are able to do today doesn't imply that it will not be, it will be the same in the upcoming future. So what's your take on that?
Yeah, so this is a very good point. It's very, very good insight. I think you know, there's sort of, on one hand, there's reason to be skeptical and concerned. On the other hand, when a group of smart people put their heads together and they come to a conclusion, you know, we have to go with what's the current belief. So that's a little bit vague, but if you take a crypto system, an encryption scheme, and you want to know, is this really reliable? We don't have a completely rigorous way of deciding that. The 2 or 3 processes are one you mentioned. Individuals who are experts in cryptography can examine that. They can try to break it. They can see if they can find a problem. If they don't, then we kind of trust it. A second is if you deploy something in practice and their hackers try to break it and they don't for 5 years or 10 years, then you think, well, this is pretty good. We're going to use it. And the third is there are automated tools and methods that people use, both to try to prove in a very, you know, rigorous way the correctness of something, or try to find attacks to prove that there's a problem with it. And that's just that's the process we have for looking at encryption. So, and I mean, you mentioned a little bit, can the future be different? It's a research topic in cryptography to see if we have quantum computing, a possible future kind of computer, will that break current crypto systems? Will I be able to steal money in the bank if I have a quantum computer? So people are starting to work on that question now and examine it, you know, in advance of the widespread availability of quantum computing. But there's nothing better other than those methods that we have now. And yet cryptography is so valuable, we use it.
Hello. Yeah. Hello, I'm Hari from School of Computing and Data Science. So since the blockchain is a peer-to-peer system, while doing the readings, they said to add a new block to the chain, we need a 50% approval from other peers. Like, how does this technically work? Is there any ways that, is there like, is there a particular program to do it, or like, is it a manual thing to do it?
Right. So this is maybe I'll say a little bit about the idea of consensus. Can you hear me? I would say a little bit about the idea of consensus and what a consensus algorithm is.
You repeat the question, please. Yeah.
The question was, he asked from some of the background material video, I think that I sent a link to, it says that in order for a block to be committed to the blockchain, let me show a little picture here. Then a large set of computers, 50% of the miners have to agree on something. And how do they do that? Is it an automated process or not? So there's several different consensus algorithms. So the picture here is to show, suppose we have this set of blocks, and these are the blocks that have been written so far. The current state of the system is the longest chain is the chain that is considered to be the truth, the most reliable. And if one node, some transactions occur and they build on the state of the world represented here, then what's the process for agreeing on the next block? So there are two very different methods. One is the method for Bitcoin, which is the first computer to produce the solution to a complicated number puzzle gets to write the next block. The other is in a system called Byzantine fault tolerance. There's a kind of a voting scheme. And there's a long history of research and computing around the notion of Byzantine fault tolerant consensus algorithms. They typically have two phases where one node is determined to be the leader. That node broadcasts to all the other systems what they think the next block is. And if all of those computers then vote among themselves and they agree that they all heard the same thing, then that's the majority vote that makes that the next block. Does that help? I think that's a sketch. So you can look up BFT, Byzantine fault tolerance, and that will explain how that works.
Yeah, so thank you. Like one other question is that while talking to question is that while talking to one of my friends, she asked me like, well, is it easy to hack the last block of the chain since it doesn't have its hash printed on the next block? Is it easy to hack it?
Not really. I mean, I think what happens if you look at this picture, suppose there are 50 miners, 50 different computer systems around the world keeping track of this. All of them will have, or almost all of them will have exactly this picture. They will know which blocks came, which ones came after the others, and what's the longest chain. And they will all agree on the longest one, or all but a few that are out of date or faulty. And that makes it there's no real way to fool the system into doing something else that way. Okay, it's a pretty reliable. It's very the algorithm behind Bitcoin and these other Byzantine fault algorithms are very, very sophisticated, and they've been studied a lot. And the reason why they work is very, very subtle and tricky to understand. But they have been, kind of scientifically studied for quite a long time. Okay. Someone else? Another question?
Hello, sir. This is Aditya from the School of Arts and Science. So my question is, knowing that there are loopholes in blockchain, that is mainly customer protection, which is not proper, why are companies like Fidelity Investments encouraging the customers to get into blockchain and do trading like with cryptocurrency, even though Fidelity their main objective is to have customer satisfaction and protect their assets properly?
Yeah, so this is, I think, really market demand. And I don't know if, this announcement by Fidelity Investments came earlier this year, and it came a little bit before there was a big crash in the value of cryptocurrencies. So I'm guessing, first of all, some people who made that decision at Fidelity kind of wished they would have waited 2 or 3 months and then thought again. So I don't, it became more controversial because of that. But I think that my guess is that a number of customers were asking for that. And so a company like that has to make a decision. What can you buy if you're a Fidelity customer? You can buy puts and calls. You can make very risky investments if you want through almost any stock trading firm, including Fidelity. And I expect that they are very clear. If you want to buy cryptocurrency as part of your portfolio, they will ask you many times over. You'll have to assert that you understand the risk, you're willing to take the risk, you're financially able to accept that risk. I think they would logically express a good deal of caution about investment in cryptocurrency. But if they don't do that, they might be missing out on important future business. And if they did the market research and they found that a significant number of their customers would like to spend a certain amount of money doing that, then I think they are, as a consumer-facing company, going to make a decision that serves their business and builds their customer base. I hope that's a reasonable enough answer. Something else?
Good evening, sir. This is Akarsha from the School of Computing and Data Sciences. So I have 2 questions, if that's all right.
Sure.
My first question is, because blockchain and sustainable development go hand in hand and have a long way to go, what is the carbon footprint of blockchain and how can it be improved?
Okay, so this, I think the main issue here is this proof of work versus proof of stake distinction. And the biggest complaint and legitimate concern around sustainability and Bitcoin, Ethereum, the large cryptocurrencies, has to do with this proof of work algorithm. And that uses a lot of computational power. It emphasizes having a lot of investment in computing and using a lot of electricity. The goal of proof of stake, which has been a lot of scientific work, has been to eliminate that problem. Ethereum has switched over to proof of stake, and this is intended to really solve or substantially address that problem. I think in the end, you have the potential with computation to do things that are much less environmentally problematic than the paper kind of alternatives that existed before. Sending something electronically is more energy efficient than putting a printout in a truck and driving it a distance. So I think we always have to be concerned about sustainability, environmental issues, but with scientific advances that eliminate the real problems with proof of work, I don't see the sustainability issue as the fundamental. It's not inherent to blockchain, and I think it will be addressed through that.
And my second question is, what is the difference between...
I didn't get that. Could you try again?
My second question...
I think you're muted, so try again.
No, sorry. Yeah, what is the difference between petroglyph and pictogram, while both types are using pictures for communication?
Yeah, I don't know a lot about that, so I'm not sure I'm going to be able to give you a good answer on that. Thanks. It looks like maybe there was a glitch here. I gave you an answer to your first question, and it could be that Siri here picked it up on my computer. Did the answer come across, or did I get lost in the...
No, I got it. Yeah.
Okay, good. Something popped up on my computer that was doing some kind of transcription, and I just wanted to check. Okay, good. Thanks.
Thank you so much.
Yeah, thank you for the questions.
Hello, sir. Good evening. This is Priyanka from School of Computing and Data Sciences. So the lecture was really insightful, and I did come up with a few questions. One of it being, how will blockchain technology and cryptography interact with supplies and consumers who expect to be paid in normal fiat currencies? How will this interaction go about, and how would you define about this interaction that would probably crop up in the future?
Yeah, okay, good. Let me give the kind of scenario that was behind the Facebook project that I worked with. So to tell you a little bit more about it, I think the Facebook projects probably started in late 2018, all right, and continued for about 2 years. It was called Libra at some point, and the plan was to build another cryptocurrency, another blockchain, independent of Bitcoin, independent of Ethereum, and then use that cryptocurrency to allow Facebook customers using Facebook or using Messenger or WhatsApp to send that currency to other users worldwide. One of their examples were one of the target audiences, and the group went around the world and interviewed potential customers. Huge investment by Facebook in this. One was people who don't have bank accounts and get paid. Could you cash a paycheck anywhere in the world and put that into their currency and then use that to buy things? Another big example for a US-based company was remittances. So you might know people who come from India to the US. Some of the salaries here are higher than someone might make in India, depending on what they do. People want to send money back home to their family or friends and so on. So the Facebook plan for that was you would use dollars in the US, you would buy their currency, which was called Libra as a prototype name, and then you would send using Messenger Libra to your family in another country, and then they would convert it into the local currency. So that's a kind of long way of getting back to the specifics you asked. The plan for most cryptocurrencies is to support exchange back and forth with other existing currencies. So you could use you could get hard currency in your country there. Of course, they were also hoping, and others who develop these things, user level currencies are hoping it could also be used in stores and so on. And that's possible. For a while, you could buy a Tesla with cryptocurrency, and then that policy was changed. But it's possible you could use them to buy goods too.
I do have another question, which is about the recoverability of electronic deposits and transactions that occur in the blockchain. Like when it comes to commercial banking institutions, financial institutions, if I lose a PIN or something, I can just go and ask them, know that I have lost it and need to recover. But in the blockchain technology, once a private key of a blockchain is lost, so are the digital assets and even all the data that was stored in it. So how will we tackle this?
Yeah, I think this is kind of in the line of this insurance question as well. That is, right now, the main users of cryptocurrencies are kind of technically, oriented people who get involved in this. They want to be early adopters. They're going to give this a try. As this moves to a kind of mass market, something that works for everyone, I think most interaction with cryptocurrency or with currency on the blockchain will go through some kind of customer facing company that will handle that for you. So if we think of it more specifically in terms of a smart contract, the smart contract, holding some money, the contract could say, this currency is owned by this person with this based on this account number. And if you have the cryptographic keys associated with the account number, you get the money right away. It could also have a clause that says another way to authenticate in the case the keys are lost is to go to some authority, the government, a big bank, another company, prove that you have this, and then that would be an alternate way to access the money. So I think that the answer is really not change the blockchain infrastructure, but build into the means by which we store things process that will work in likely unusual but unfortunate circumstances that let us recover lost money. And I think that can work. It's certainly consistent with the principles here and would be a good approach.
Thank you, sir.
Sure.
Hi, this is Anirudh Tyagi from the Computing and Data Science School. I have a question regarding different SHA models. So the question is, how are SHA 256 and 2512 different? Is this something has to do with the round computational steps in the asymmetric hash algorithms or something more foundational?
I think I'm not going to be able to give you like a detailed answer on this. So SHA is the secure hash algorithm for people who are not familiar with it. 512, 256, these are the length of the hash that's produced. I don't really know the details off the top of my head about how different and how similar the two SHA algorithms are for that length. So I'd kind of commend you for being up on the technology and getting into the detail of the question, but I think you'll do better just to Google the question and look up the answer. Okay.
Okay, thank you.
Sure.
Hello, sir. I am Ashwath from School of Law. And my question is about cryptocurrency. I don't think I've understood the concepts well, but my question is, so cryptocurrency, I view cryptocurrency as a mode of exchange. So in the right now, there's a transitioning from banknotes to cryptocurrency, right? So in the past, when John Law made a transition from using gold and silver as a mode of exchange to using banknotes, people were fine with it in the beginning. He took gold from people and issued receipts as banknotes, and everyone used it. But after a while, when John Law started to produce too much of it, people started protesting, and there were conflicts over that. So do you think people would continue to place their trust on cryptocurrencies on a long term?
Good. So this is a good question. It's something that I puzzled over and thought about a good deal when I was working with this Facebook group. Like, if they're going to create a cryptocurrency, what's going to give this thing some value? Why are people going to want to hold this currency? Why would I turn my good dollars into this funny new thing that's really just a bunch of bits in a computer somewhere? Think that sending a message to someplace somebody else would work. Why is that going to work? And what I came away with, convincing coming to the conclusion is the value of a currency is based on the market that supports it. So if there are many ways you can spend that money, as long as they persist and those are available, that will give you some assurance that the currency is worth something. So if you could buy food, if you could buy real estate, if you could buy tangible goods with the currency, then you know the currency has value because somebody will give you back hard currency for it. So I think that to me was the thing to watch in seeing whether the currency was valuable is who would accept it as payment. And once you have that, then you have something of value. If people stop accepting it as payment, people stopped accepting gold as payment. There's nothing really that useful about having a pile of gold. It's just kind of the convention that we associate that with. We use that as a currency because it's durable and because people seem to want to accept it in exchange for goods. I hope that's helpful. That was my armchair economist, way of resolving it to myself. I think I can see you have a microphone, but I think you're muted there. Thanks. I don't think it's the microphone. I think it's the.
Hi, sir. I'm Tanya Kamakshi, and I have a question. So, what is the future of blockchain?
What is the future of this? So, I'm not sure how to answer that. So, this blockchain is a technology. There are many current uses of it. There are these widely used cryptocurrencies, Bitcoin, Ethereum, and some less popular ones. There's also, maybe I'll give you another answer that's in a different space. There's an organization called Hyperledger. I think I have somewhere a picture about that. Hyperledger is a open source shared consortium of people working on blockchain technology for various uses. Here are some of the companies that have invested in that. These are some of the primary companies. Here's a bunch of other secondary companies that are also participants. There are really hundreds of companies that have decided they want to experiment with blockchain technology for the purpose of making something that they do in their business occur more efficiently. So I think that the future is a little bit of it is, to go back to this picture, some piece of it is in this money and banking area. And another big piece of this is, here's a way when you want to have consistent shared information across a lot of different organizations in different locations, as you would in any global company. Blockchain technology can be a very powerful and efficient way of maintaining a consistent record of things that have happened.
Thank you, sir. Thank you so much.
Hello, sir. This is Anya Raj from the School of Arts and Sciences. So can you hear me?
Yes.
Yeah, this is Anya Raja from the School of Arts and Sciences. My question is along the same lines as my peer who had asked about the exchange of gold and cryptocurrency. So where do we strike a balance between the use of digital currency and physical currency in the economy? And do you perhaps foresee a major instability in the financial market in the future due to the lack of a balance?
Yeah, I think it's really, physical currency is a common thing for, you and I going to places and buying things. But if you looked at a global scale, what is the exchange of euros to yen to dollars to something? This is all digitally mediated. Nobody's sending bills back and forth for that. So I think that, the biggest instability in global markets has to do with, financial trends. The cryptocurrencies maybe here's another part of it is they seem to fluctuate of their own, which is, highly volatile for many people. I have in here at the bottom here this notion of stablecoin. There are the fact that cryptocurrency floats wildly is a choice, design choice. It's possible to build a cryptocurrency that is going to maintain its value relative to another currency by instrumenting a process to do that. And there have been a set of stable coins. There's a way to make a cryptocurrency no more volatile than other currencies. So there are many different points on the spectrum and many different possibilities on how things might work out.
So am I audible?
Yes, yes.
Yeah. So I have two questions. So in the recent years, metaverse has grown in popularity. So how does blockchain fit into the metaverse?
Well, let me give you some answers. Some examples. I think the idea of blockchain, the technology is being used primarily for recording ownership and transfer of value. And for one example, there are some gaming environments where success in the game earns tokens. Those tokens can be represented on a blockchain and exchanged with other players or used to buy things that are important in that virtual environment. So if you're a warrior and you're successful, you get some tokens, you use the tokens to buy another shield or another weapon or a sword, and accumulation of status in the game is based on tokens that are based on blockchain. That's a kind of example.
So my second question would be, so instead of auctioning and selling world famous art pieces, can it be converted to an NFT? And would there be any advantages by using this method?
I think what can be could be interesting in the physical art world, and this is sort of my speculation, but you do have occasionally something about a piece of art there's controversy about whether it's actually legitimate or whether it was a forgery. I think there was an example in something very high profile, and I've forgotten what it was, of somebody had stolen the authentic piece of art from a place it was displayed and replaced it with a copy. I think you have the possibility maybe in taking very, very high quality representations of something and storing in some reliable way the provenance, the history around something to distinguish over time authentic from forgery. I don't know if that will really work, but that's one guess, let's say. Here's a challenge. See if you can figure out a good way of using reliable storage of information to address the problem you mentioned. I don't know if there's a good answer or not.
Hi, sir. This is Sriranjani from School of Law. My question is, how many cryptos are known so far in human history?
I'm sorry, can you repeat that again? How many what's?
How many cryptos are known so far in human history?
How many cryptographic?
How many cryptocurrencies?
How many cryptocurrencies are there? Okay, so there are quite a few. Maybe I have a little picture here of some. And the reason why there are quite a few is there are some underlying currencies, chains like Bitcoin and Ethereum. For these blockchains, they have their own currency that's native to that blockchain. And then there are derivative products that are based on those that are effectively operate as different currencies. So that's what many of these other things are below that. You could have something that you call a currency, it's pegged to the rupee, it's pegged to the dollar, or it floats according to some average of those things. But it's really implemented by contracts on Ethereum. This is just a few of the top ones, and some of the market cap in large amounts of money and large amount of trading volume per day. This list goes on, and there must be a couple hundred of them. You could look that up. Okay. Should I take any? I don't know if there's anything from the written chat that's different. I think we're coming.
There's another hand here in the room, but maybe if you want to take some questions from the chat.
It's good. There's a. Let me take a look here. Somebody said, it looks like to create good contracts, you would still need lawyers. I think that's, you would still need expert. There's a role for experts in that. Let me look maybe at the bottom here. Many of these things have come up in the discussion already. So I expect let me take something from the room and then see if we come to time to wrap up at the top of the hour, maybe.
So,
yes.
This is Mehan from School of Computing and Data Science. My question is cryptocurrency the final stage of currency, or can you picture another sort of currency which comes in the future?
Good question. I think it comes down to what do you mean by, what does it mean to be a cryptocurrency? And so, this field is about, recording ownership, somebody's balance of currency holdings on a blockchain. And I guess I'm imagining, one possible future is that this is a good technology for interfaces between central banks. I was actually involved in some discussion. I don't know what's happened to the group, whether they've proceeded in the same way or not. But a group of central banks of 10 or 12 through the UN, large countries with large economies, we're looking at Bitcoin, at blockchain as a technology for managing the exchange of those currencies between, in a way that was sanctioned by the central banks. So I think it's, in a way, as a user, it's not going to matter exactly whether someone keeps your balance of how much money you have on a blockchain or in a bank. But my guess is the future financial infrastructure will have interconnections between all of those different kinds of organizations. Banks might exchange money between banks using whatever the best future technology is, and current indication is something like a blockchain, meaning something governed by a consensus algorithm among a number of parties, with none of them being the single authority, is a good method for banks to agree on a set of transactions. And it might be the best kind of method in the end for agreement between the organizations that manage each regional or national currency and the exchange between them. So it's a pretty general idea that, the store of, your store of money is no longer how many gold bricks you have in a box somewhere, but it's a digitally maintained number. And there is some comfort, I think, in having that number not stored by one bank system in one place, but distributed in a way that it could be recovered if there's any problem. And some evolution of this technology seems like the way international banking is likely to go.
Thank you, sir.
Any other questions here in the room?
I think if we're winding down, what I would suggest is, I put at the end of this some future, resources. There are lots of good explanations. It's hard to sort out what's a good explanation, but I tried to give some short ones here. There's lots and lots of information online. There's lots of ways to follow up if you have further interest. I'll be there. I'll be happy to talk with people about various things there. One source are these short explanations that you can find by web search. Another source are lots of university courses around the world taught on this topic and related topics. In our field in computing, it's quite common for people to put their teaching material, their course syllabus, their reading material, their homework assignments on websites that everyone can view. So that's likely available. Look for, the Princeton group who wrote a book on blockchain. Look for the course material they have. And, please enjoy following up. I hope I gave you some initial thoughts about this and why it could be useful. And there's much more material available online, and I'd be happy to discuss with further by email or in other ways if you got interested and would like to do that.
Thank you, John. Please join me in congratulating him. Consider this to be just a sneak preview, because John Mitchell will be here physically, January 2nd through January 5th. John, that's the week.
Yeah, that Monday to Friday week.
And I warned him that we're going to keep him very busy, because I want him to engage with you and you with him, take full advantage of his knowledge and experience and the sheer breadth of the connections that he's helping you make between computer science, law, arts, everything, finance. This is an ideal example of the purpose underlying the Frontiers course, which is to give you a glimpse of the frontiers of knowledge, okay? The very, very horizon where new knowledge is being created, in the words of the people who are actually creating that knowledge, okay? Usually you don't get that kind of thing until you get to a PhD program at a top university where you get to hear from the people who are creating the new knowledge. This is it. So I also want to say I'm proud of the students. I thought the questions were very thoughtful, strong, and it sounds like you engaged with the material well, you prepared well, and we look forward to January when you can follow up much more. So thank you, John.
You're great. Thank you.
Okay.
Nice to see everybody. Thanks a lot.